Section 5.4, Multiplying and Dividing Radical Expressions. This begins on page 170. Question 1. Fill in the blank to make the statement correct. A. Changing a radical in the denominator of a fraction to a rational number is called rationalizing the denominator. We're going to be doing this a lot because in the denominator of a fraction, you're not allowed to have a root of any sort or radical of any sort. And so the process to change that is called rationalizing the denominator. B, in the fraction 3 over root 2, the 3 is called the numerator, and the root 2 is called the denominator. C, 2 plus the square root of 5 is the conjugate of 2 minus root 5. And we're going to go over more of what a conjugate is. Basically, when you multiply them together, so say we go just use variables, so a plus b, and the conjugate of that is a minus b. And when I multiply it together, so I FOIL it, you get a squared plus b squared. So that has no middle terms. And so that is a way we can use to rationalize the denominator. To rationalize the denominator of 1 over root x, so that's what we're looking at, that root x part, the numerator and the denominator are multiplied by root x. And the reason we do that is mostly for the denominator because I know root x times root x is root x squared, and the root of x squared equals x. So now I do not have a root of any sort in the denominator. And then the numerator, we just go 1 times root x. E, to rationalize the denominator of 1 over root 2 plus 1, the numerator and denominator are multiplied by the conjugate. So we're multiplying it by root 2 minus 1. And if I do that, put some brackets around these. So I'm going to be FOILing. Root 2 times root 2 is root 4. Root 4 is 2. And then I'm going to have a minus root 2. Plus root 2. 1 times negative 1 is negative 1. So I get 2 minus 1. 2 minus 1 equals 1. So I'm just looking at the denominator here. And then the numerator I just do as well. So that'll be 1 times this. Root 2 minus 1 at the top. So the answer here would be root 2 minus 1. Question 2. Multiply. All variables represent positive numbers. Express answers in simplest radical form. 2h. 4 root x times negative 3 root x. Okay, there's two methods here. Let's do method 1. 4 times negative 3 is negative 12. They're both square roots, so we'll just multiply what's inside. X times x is x squared. The root of x squared is x. Method 2 is just using fractional exponents. 4 times x to the half, and then we have negative 3, x to the half. 4 times negative 3 is negative 12. When we're multiplying, we add the exponents. 1/2 plus 1/2 is 1, so negative 12x. 2n. 4xy times the cubed root of x squared times y times 3xy cubed root xy squared. Okay, again, method 1. 4 times 3 is 12. X times x is x squared. I'm doing this stuff outside of the roots right now. Y times y is y squared. They're both cubed roots, so I can multiply them easily. I'm going to multiply what's inside. X squared times x is x cubed. Y times y squared is y cubed. Cubed root of x cubed is x. Cubed root of y cubed is y. I'm just going to put these together. Method 2, I'm going to be using fractional exponents. So let's distribute those fractions first. So x 2 times 1/3 is 2/3. Remember there's a 1 with my y, so 1 times 1/3 is 1/3. Same with this x, so it'll be x to the 1/3 and y to the 2/3. 4 times 3 is 12. When I multiply my variables, I actually add my exponents. So let's do our x first. We have 1 plus 2/3, 1 plus 1/3. Well, 1 plus 1 is 2. 2/3 plus 1/3 is 1. So I have 3. So x cubed. Add the exponents for y's. Here we have a y to the 1, y to the 1/3, y to the 1, and y to the 2/3. 1 plus 1 is 2. 1/3 plus 2/3 is 1. So y cubed. 3. Find each product and simplify. If I have something simple like this, remember I am going to be distributing that 3. So I would have 3a plus 3b as my answer. I'm going to do the same thing here. It looks a little bit more complicated, but the process is exactly the same. So I'm going to be taking my first term and multiplying it by the first term inside the brackets. They both have a cubed root, so I don't have any problems with my roots. If they were different roots, I would have to use exponents. 2 times 5 is 10, and now I have my cubed root. 2 times 4 is 8. 2 times 3 is 6. 2 times 2 is 4. The cubed root of 8, well, 8 is 2 times 2 times 2, so the cubed root of 8 is 2. So I have 10 times 2 is 20. And I can't simplify the second term at all, so I just leave it like that. 3j, root 5 plus root 2 squared. Okay, remember the square belongs to everything in there, so it is not root 5 squared plus root 2 squared. I actually have to rewrite this and FOIL it. Root 5 times root 5, root 5 times root 2, root 2 times root 5, root 2 times root 2, root 10 plus root 10, we can put those together because they both are square roots and they have the same thing inside, so we can add like radicals. So 2 root 10, root 4 is 2. Let's put our numbers together. So 5 plus 2 is 7. Copy the rest down. Question 4. Find each product and simplify. Assume all variables are positive. Square root of y plus 1 plus the square root of y minus 1 times square root of y plus 1 minus the square root of y minus 1. We're going to have to be very careful when we FOIL this. Okay, they all have square roots, so I'll make it a little easier. We'll do first term times first term. So to write down our square root sign, we'll have y plus 1 times y plus 1. Outer terms, a negative sign, so we'll keep that. Y plus 1 times y minus 1. Inner terms going to be positive. Our square root inside that is y minus 1 times y plus 1. And last terms, positive times a negative is a negative. Square root y minus 1 times y minus 1. So we need to simplify the stuff inside the square roots first. Okay, so this one here is, you know what, I'm just going to write it as y plus 1 squared. And the reason why is I'm going to take the square root of that, so that becomes y plus 1. Okay, let's go to the yellow one. When I multiply this out, I get y squared minus y plus y minus 1. That's y squared minus 1. Do the blue ones, y squared plus y minus 1. So that becomes the root of y squared minus 1. Pink one, negative. I'm just going to write this as a square as well. Take the square root of y minus 1 all squared. It's going to be y minus 1. Okay, so I have y plus 1 here, minus, these have, the two middle terms have the same type of root and the same thing inside the root. So I can now add them together. So negative 1 plus 1 is 0. So that looks nice. And let's distribute this minus sign. So I'll have a minus y plus 1. Y minus y is 0. 1 plus 1 is 2. Question 5. Perform the indicated operation and simplify. Assume all variables represent positive real numbers. Square root of ab cubed divided by the fifth root of a squared b cubed. There's no way around this one. We have to use fractional exponents. We have a square root and a fifth root. So to simplify this, we have to use fractional exponents. Okay, let's distribute those exponents. And we will now use our exponent rules. When we're dividing, we subtract the exponents. Okay, so I'm going to do my a's first. So 1/2 minus 2/5. So I do a to the 1/10. And for b, 3/2 minus 3/5. I can rewrite this with the square root, so the 10th root of ab to the 9. Please know we're going to be wanting to have positive exponents. So if they are negative exponents, you do have to take the inverse to make it into a positive exponent. 5n. Cubed root of 2 minus x to the 4th divided by 4th root of 2 minus x cubed. Again, we have different types of roots, so we have to use fractional exponents. We use multiple brackets. We'll multiply the 4 by the 1/3 and the 3 by the 1/4. Now our base is going to be 2 minus x. We can keep that. We don't have to do anything with that right now. And we can now subtract our exponents. So we have the 12th root, 2 minus x to the 7th. 6. Determine what the fraction must be multiplied by to rationalize the denominator. A, 1 over the square root of x minus 2. Well, the whole thing is underneath the root, and I know if I multiply the denominator by x minus 2, I'm going to get the square root of x minus 2 squared, which will now give me x minus 2, and that's what I want. So I'm going to multiply the bottom by this, but because I can't break math rules, I can really only multiply by the number 1. So I'm going to put the same thing on the top. So this whole part here in green, that really equals 1, and I can now multiply by it and not change the question. This would be my answer. 6e. This one's a little trickier. I don't have everything underneath the root sign. I have a plus sign here, so really my denominator is split up into two different terms. So that is what I need to use a conjugate. So I'm going to be multiplying it by root 2 minus root 3. Yes, I am focusing only on the denominator. Now if I multiply it by that, and I FOIL this, I end up with a squared minus b squared. That is what I want. If everything's in squares, I can take the square root of it, and I have just no root in the bottom, which is what I want. So, but I have to multiply it by 1, so it has to be the same on the top. 7c, simplify if possible. Root 6 minus root 3. Well, they have different numbers inside the root, so I can't really add or subtract them. They are both square roots, but it has to be the same stuff inside as well. Let's try it as fractional exponents. Again, when we're adding or subtracting, we need to have the same base. So since we have a 6 and a 3, that is not going to work. 7g, root 3 divided by 4 root 3. Well, the root 3's will cancel. See, I can rewrite this as 1/4 times root 3 over root 3. Root 3 divided by root 3 is 1. So 1/4 times 1, that will give you 1/4 or 1/4. Question 9. Rationalize the denominator. Write the quotient in lowest terms. Assume all variables are positive. D. 5 minus root 2 divided by root 3. Okay, so we're going to rationalize the denominator. So times top and bottom by root 3. So root 3 over root 3. I'm going to do the bottom first just to double check to make sure it works. So root 3 times root 3 is the square root of 9. And the square root of 9 is 3. Let's do the top. I have to remember to distribute this root 3 to everything. So root 3 times 5, 5 root 3. Root 3 times negative root 2, so that'll be a negative. 3 times 2 is 6. And I can't add or subtract those because I have a square root of 3 and a square root of 6. Those are different. We'll just copy those down in our answer. 9j. Root 5 divided by root 2 minus root 3. We have two terms here. There's a minus sign. We're going to take the conjugate. Same thing written for the numerator. And now we need to FOIL. So I'm just going to put brackets around everything. Again, I'm going to start off with the denominator. So root 2 times root 2 is root 4. Square root of 2 times root 3, square root of 6. Negative root 3 times root 2 is negative root 6. Negative root 3 times root 3 is root 9. So we have root 4 is 2. We can add those two middle terms together because they're both root 6s. So 1 minus 1 is 0. Minus root 9, that would be a minus 3, which gives a negative 1. The numerator, root 5 times root 2, is negative root 10. Root 5 times root 3 is positive root 15. Can't simplify those two. Okay, let's make the negative go out in front. And distribute that negative 1, so negative root 10 minus root 15. Question 14. The volume of a pyramid is V equals 1/3 B times H, where B is the area of the base. If the volume of a square-based pyramid is 300 meters squared, they give us a number, I'm going to write it down, meters cubed, right? Yeah. And a height is of 9 meters. What is the length on one side of the base? A square-based pyramid, so this is going to be a square. Each length is going to be equal. B is the area Now the area of a square is s squared, where s equals, well, switch the letters around. Maybe I should put this as an s. So I need to find s. Okay, well, let's first plug in our numbers. Our v is 300. Our b is s squared. And our h is 9. Put our numbers together. 9 divided by 3 equals 3. Divide both sides by 3. And take the square root of both sides. The length of one side is 10 meters.